Okay, for our next big section of vocabulary, I think this first term might be the only one that's kind of new. So what an angle bisector is, all right, is a line, ray, or segment that splits an angle into two congruent angles, okay? So let's go ahead and draw that picture. So let's start by drawing an angle. Okay, remember that they are rays, so we're going to put arrows, and then let's put 3 points along that angle. Okay, and let's label it M, N, and P. So an angle bisector says the line, ray, or segment that splits that angle into two congruent angles. So we're going to draw this in the form of another ray. So this other ray has to pass through the interior of that angle. It shares that vertex as its endpoint. And let's go ahead and put another point along that ray, and let's label that R. So NR, so this ray right here is my angle bisector because it's bisecting the full angle of MNP. So what does that mean? So what it means is that it splits that angle into two congruent angles, okay? Now, we've talked about congruent segments before. And what congruent segments are segments that have the same length. And if you remember when we were talking about congruent segments, if I'm just going to go over here real quick, if these two segments are congruent, remember how I notated those to be congruent was through those little tick marks. So we have our own version of the tick marks when we're talking about angles, and what they are is they're swoops, okay? So if I'm trying to communicate that these two angles, MNR and RNP, are congruent, I'm going to add those little swoops inside those angles, and those two swoops are saying that these two angles are congruent, okay? So an angle bisector is a line, ray, or segment that splits an angle into two congruent angles, okay? Now, let's actually segue. All right, I'm actually going to come all the way down here to congruent angles. So what congruent angles are, and I know I've already used this vocabulary term, all right, but what congruent angles are angles that have exactly the same measure. So what that means, all right, so angles that have exactly the same measure. So what that means is if this angle up here of MNR is 30 degrees, then angle RNP also has to be 30 degrees. So those measures have to be the same, okay? And we notate it by those swoops. Now, if I wanted to write it out that those two angles were congruent, all right, we're using that same notation of that equal sign with the squiggle on top. So I could state angle MNR, which is this angle right here, MNR, is congruent. So I'm using that little equal sign with the squiggle on top to angle RNP. So two different ways of writing out that those angles are congruent. Okay, so now let's go to the vocab. All right, that should make sense to us because I think this is some prerequisite knowledge. So an acute angle is an angle that measures less than 90 degrees. All right, so an angle that measures less than 90 degrees. So we're just going to draw a really quick picture. An acute angle would look something like this. Okay, its measure is less than 90 degrees. Let's say that this is about 47 degrees. All right, and obviously 47 is less than 90, so that angle is an acute angle. Okay, now right angle is an angle that measures exactly 90 degrees. So to draw that, we're going to go ahead and draw an angle that appears to be 90 degrees. But just having an angle that looks like it's 90 degrees is not enough information to actually state that it's 90 degrees, all right? This right here that I drew could be 91 degrees, all right? So in order for us to communicate that this is a 90-degree angle, we need that little box in the corner, all right? And that box is saying that that angle measures exactly 90 degrees. Now, an obtuse angle is an angle that measures more than 90, but less than 180 degrees, okay? So more than 90, but less than 180. So we're going to go ahead and make this at about, let's say this is about 120 degrees. So this full angle right here is 120 degrees, okay? And then the last one is an angle that measures exactly 180 degrees. What that looks like is actually just a straight line. Now, remember, it is still an angle, so we're going to put 3 points on there, okay? And the middle point is actually the vertex of that angle. Right, but this full angle right here is 180 degrees. So straight angle measures 180 degrees. So let's jump to example 2, because example 2 is asking us to classify each angle as either acute, right, obtuse, or straight. So if angle A is 130 degrees, that's more than 90, less than 180, which means that this is an obtuse angle. Angle A is equal to 90 degrees. All right, it's exactly 90 degrees, which means that angle A is a right angle. And then our last one, angle A is equal to 45 degrees. That's less than 90, which means that it is acute. Okay. So our last term before we take a quick break, all right, is congruent angles. And I know we just talked about that, but I want to go over it again, okay? So congruent angles are angles that have exactly the same measure, okay? So if I just wanted to draw a really quick picture in here. Let's have this angle, and let's call this angle 1. And we're going to have another angle that's not touching it. Let's call this angle 2. And how do I mark on the pictures that those are congruent? Well, I mark it through the swoops. All right, so I have those 2 swoops. So those 2 swoops are saying that those angles are congruent, okay? I could also write it out that angle 1 is congruent to angle 2. Now, what that means, one more time, all right, is that if angle 1 measures 50 degrees, what does angle 2 have to measure then? If they're congruent, well, that would be that they both have to equal 50 degrees, okay? All right, I'm going to pause here, and then we're going to come back to angle addition postulate, and then we will go from